in your computer?
Yeah.
Unmute yourself.
I'm unmuted.
Okay.
John
Right.
Romaine has been corresponding with me. John, can you hear me through this microphone? If you wouldn't mind typing that in, he's saying no. Okay, and still no.
I could hear you.
You can hear me. My sound check doesn't change. Network quality good, estimated audio quality good. I can hear you. Jay Tanner says he can hear us
Okay.
or hear me through my mic.
Can he hear me? Or am I too far away?
I don't know, you're coming through here.
Yeah.
I can hear you a little muffled, but okay, says Mr. Tanner. Thank you, Jay.
All right. So what if we move you a little bit closer this way?
Closer
Yeah.
to you
Yeah.
today?
Just yeah,
Right now?
Right now, yeah. I want to get this going for everybody.
I understand. Oh, gremlins today, people. Just please be patient.
Yeah. Yeah, at least if they can hear me, they can kind of, see what's going on here. And
All right, we're just trying one more thing. Just to let you know, we are changing cameras.
nothing.
The camera's not recognizing.
Is it not charged?
They're both fully charged. Back to this one.
Hey, Robbie, why don't you come over here and tell us about yourself? as we try to get this going.
Well, if we have to, I can hook up my computer and do a live from my computer.
Yeah, we could.
I'm not going to have the unit as the backup, but as a visual. But that's something that we could do at least to get the webinar up.
Rod, do you see the light on your end on the camera?
Yeah, it's green.
Oh, it's green. It's not even recorded. It's not live. Do you put
Flash,
dedicated webcam mode?
flashing green.
It's flashing green?
Yeah. That's like waiting for a signal, right? When it's flashing green?
Yeah.
Other,
Hold on, guys. One more try. Something else. We're on wired webcam mode.
Is the microphone volume on the computer off or something?
I don't know. I don't know. Everybody, you may be in luck. I think Rob's going to belt into a song soon. What do you want to sing, Rob?
I like, I'm privy to the sound of silence, but
This
the disturbed version.
Disturbed version?
Disturbed version,
Yeah.
yes.
Very appropriate for
There we
you.
go. Using the word.
All right, one more time. Can you hear us?
Wonderful.
My mic is on.
Okay, he's gonna have to use that mic.
Put your
Really?
computer near him.
Okay,
Okay.
coming close.
All right.
You gonna want the catalog?
Yeah, I'm just going to show it as a visual. I believe we have it in the handouts. Yes, we do.
Or if you want to reference a page or something.
Yeah, sure. Yeah, just leave it right there. I'm gonna be up and about. If I stand up, am I gonna be?
I cannot
All right.
check questions then.
Well, that's why I was saying if you bring that table over this way, you can, they could still hear me and you could still see the screen in case we have questions pop up.
Okay, am I gonna be in the way?
Probably, but it's all right. You're a good looking.
I am good looking.
Actually, if you lean back, then they can't see you. All right, so do you guys hear me at the moment? I want to make sure that we have sound here. Can hear. I can hear you. Okay, awesome. All right, so I apologize for the delay. If you didn't hear me before, I do want to send out a congratulations to Brian Ferraro. He was our winner in the Wheel of Names. So basically, from last week, him being attentive and also being involved in the conversation, we entered his name onto this Wheel of Names with the other participants. And we do our drawing weekly. So next week, anybody who joins this webinar will have the same opportunity. So we encourage you to be involved. And without further ado, let's get to the presentation. So my name is Rob Clemens. I'm with Wales-Darby, part of the Contractor Services Group, and also our new brand, the HVAC Insiders. That is www.hvacinsiders.com if you want to get more training. We have probably close to 200 videos up. We've been doing these trainings now since basically the quarantine situation started last year with COVID. So we have a plethora of different kinds of training videos available to you.
Big word.
A plethora.
Yeah, I can't even say it.
So with that being said, there's a lot to go over and we already lost about 15 minutes in time. So I just want to jump right into this. Chris, can I have clicker control? Good. There we go. All right. So the Fujitsu Multipositional Air Handler, we have 4 different size units available in the system lineup. We have a 2, 2.5, 3, and 4 ton. So when looking over this equipment, you might say that it looks a lot like the standard unitary equipment that Fujitsu had been releasing that was basically Rheem branded or Fujitsu branded Rheem equipment. But the look is basically the only thing that's really going to be similar. When looking at our condenser compared to a traditional condenser, we get a multitude of different advantages as far as the system is concerned. So one thing, we have an inverter DC compressor. All right, metering device at the indoor unit, outdoor unit as opposed to the indoor. We have our electronic expansion valve is at the outdoor unit. That is for precise refrigerant control, whereas the TXV, which is located at the indoor unit, just kind of maintains the differential between the two. We also have a variable speed fan motor, and one of the key benefits here is the outdoor unit is going to power the indoor unit, therefore we do not need a home run to the indoor unit. Now that's one of the reasons why I am so excited about this equipment. It's a game changer to me, so much so that I'm going to be installing this into my own house. So by the end of this presentation, I hope you understand really why I have so much excitement revolving around this product specifically. So we have the ability to mount this unit in 4 different positions. We have a horizontal left and horizontal right, as well as a vertical upflow and vertical downflow. As you can see, our units operate in cooling from -15 to 115 degrees and in heating from -5 to 75 degrees. So key aspect, key takeaway from that is going to be if we need to use this unit for a server room type of application right here in our footprint, we are going to be able to provide that with the system, being that we can cool down to -5 degrees. All right. So some of the specifications, this is all going to be coming right from our Fujitsu full line brochure, which I have right here in front of me. You also have a copy of that. If you take a look in your control panel on the top right-hand part of the screen, you will have the downloadable version of this brand new Fujitsu full line brochure that just came out roughly about a month and a half ago. All right, so that's hot off the presses. It does have this equipment in it. So the key takeaways from this, we want to make sure that you guys are able to understand the efficiencies of our equipment. The efficiencies, that is going to go a long way in determining whether this equipment is going to be available for rebates and/or federal tax credits. So as you can see, we are above 16 SEER and above 10.0 HSPF. So that means in most cases, well, in some cases, we're going to qualify for these rebates, depending on local jurisdiction, local code, and local utilities as well. The other thing, static pressure, we are able to go from 0.1 to 1.0 inches in water column, and basically that means we can cover any, basically any kind of ducted system that you could see in a in a home type environment, residential type ductwork. As far as retrofitting is concerned. We can do whole floors, we can do whole homes, depending on the sizing of the equipment. All right, so next thing that I want to discuss as far as the specifications are concerned is our piping. All 4 of our units have 3/8 and 5/8 piping, and we have to follow specific parameters just like on our standard mini split equipment. Mins and maxes, not listed here as the minimums. We want to make sure that we're over 16 feet of copper going in one direction, not both ways. Okay, you can't do 8 feet and then 8 feet back. It's got to be 16 feet from point A to point B. And then on the 24 and 30, we have the ability to go to 164 feet, and the 36 and 48,000 BTU units, we could go all the way up to 230 feet. So just some comparisons on our equipment here with some of the competition. All right, we're not going to go into specific names here, but you can see unit F, M, and D up there. Fujitsu is unit F. You can kind of figure out which the other 2 are, but once again, not saying any names. You can see our SEER rating is right up there with the top of the line equipment that is out there on the market. Then when we got up to the 4-ton equipment, see the same thing, but in this case, unit M does not even make an offering. All right, so advantage Fujitsu as far as that's concerned. So another advantage of the Fujitsu equipment, as I stated earlier, we could qualify for these rebates because of the comparisons in the HSPF there. So we are over 10 HSPF and over 16 SEER, so that opens up the door to those rebates where, as far as the other guys are concerned, they're going to be below that range on the 2-ton, and with the larger equipment as well, they're going to be falling under that 10 HSPF rating. And once again, no model lineup on M. So as far as rebating is concerned, that's a check mark in the Fujitsu column. So all of our outdoor models that we are listing here for our multi-positional air handlers are going to be -5 to 75 degrees in heating. When we're talking about -5 degrees, that doesn't mean that the systems are going to cut off at -5 degrees. That just means we are going to lose some of the capacity that we are able to produce as the temperatures go even further below those lines. So what I'm talking about in referencing this chart here, you could see -5 outdoor temperature, outdoor dry bulb, Fahrenheit, 70-degree indoor, and we are producing 28,830 BTUs on our AMUG 36 LMAS, or our 36,000 BTU unit. Okay, so in our territory here, New York and New Jersey, we're not going to be going by that -5. That is a design temperature. All right, so we're going to be operating in temperatures that are a little bit warmer than that. We'll get into those in a second. But first, I want to kind of compare to another unit that you might see out there, Unit B. This is one of the units that people talk about out there as kind of like the I don't like to use the word, but idiot-proof install, because because it's the ability to adjust to static pressures, right? But if you take a look at this unit at 70 degrees, same indoor temperature, and at 21 degrees, I'm sorry, at -4 degrees rather, roughly the same outdoor temperature, we're only producing 21,000 BTUs from that system. So already you can see that there's an advantage here, clear advantage as far as the heating is concerned. We are producing more heat from our system than some of our competition. All right. So another thing I want you to take notice to as we look at this chart, let's keep that 70-degree indoor temperature and let's follow it across. We'll follow that line straight across. And where does that system cross 36,000 BTUs along that 70-degree indoor temperature? And the answer is it doesn't. All right, so this unit with a 70-degree indoor temperature never crosses 36,000 BTUs. As a matter of fact, there's only a few places where it actually will produce more. That's with a 60-degree indoor and 42 degrees outdoor and up is the only time you're going to see 36,000 BTUs on that chart. So once again, advantage Fujitsu. So some other key differences between the two. Outdoor unit decibels, our system is very quiet. Our compressor is located inside that closed-in compartment, and it also has a sound insulator around it as well, so you don't hear our systems running. Cooling operating range is another difference. We can go down to -5, where competition typically, stops around 15 degrees. All right, maximum line set, we go longer and even have a smaller footprint. But now getting into more relative information, one of our territories up here is in Hudson Valley, New York. My good friend and colleague, John Resso, controls that territory up there. This is the temperature that he's going to be seeing. So in taking a look at this chart, we're going to go with the -5 because the design temperature is 6 degrees in that region. Follow that 70-degree indoor temperature, and there we go. We have 32,900 BTUs. So we're able to produce more heat in this instance because the outdoor temperatures are a little bit higher, and that's basically what the design temperature is all about, figuring out what your design temperature is for your specific area and then sizing your equipment accordingly. So that's not to say that the 36,000 BTU is going to be insufficient for this territory, because we do have the options, which I'm going to get into in a little bit when we are talking about our heat element kits that we can install in the air handler. All right, so we can make up for those temperatures if need be. All right, so then moving along down here in mine and my good friend and colleague Jim DePalma, who's sitting here next to me, in our territory here in basically most of New Jersey, we fall into the 14-degree category. So in looking at the chart here, taking a look at 14 degrees, 70-degree indoor temperature, that's 36,750 BTUs on our 36,000 BTU unit. So we're actually producing more. So this unit is sufficient for our territory. Not to say that you shouldn't install one of our heat kits as well, because if you install one of our heat kits, you kind of have that redundancy in case your heat pump isn't able to handle a certain capacity, or for whatever reason, you have that backup. So just a few things there. These charts can be found on the design and technical manual, or I should say in the design and technical manual on the Fujitsu portal at fujitsugeneral.com. And Jim, any questions as far as the product is concerned?
Yeah, you got two questions here.
Okay.
And since you were just focusing on temperature, the question is, what happens if the out in the outdoor unit in cooling, if the temp goes below -5 degrees, or in heating, if the outdoor temp goes above 75 degrees?
Yeah, so in those instances, we want to protect the system. So in heating, we are not going to operate past 75 degrees. That is a protection that is built within the system. So that's just to protect it from overheating. And as far as the cooling being over 115, you said?
No, if the outdoor temp is in cooling and goes below -5.
So I believe, not 100% sure on that, the -5 degrees is going to be a cutoff point as far as that unit is concerned because of refrigerant temperatures and freezing.
All right, and there's another one.
Yep.
This is an interesting one. If you're replacing a 2.5-ton system, can you use a 2-ton Fujitsu if the BTUs match the design temperature? Ah, somebody's thinking here.
Okay, all right, so we could break that down a little bit. First things first, most importantly, no matter whether you're coming into a new home, whether it's a new construction home or you're going into a home that has an existing HVAC equipment, never go by the nameplate of what that existing equipment is. We don't know if those people before you have done a proper heat loss calculation on the system. So most importantly, the first thing we want to do is we want to match our indoor unit, our system rather, to the design of the home, not to the design of what the equipment was. So do a load calculation, make sure we have exactly how many BTUs we need to cover, and that's how we are going to size our equipment. So it's one of those things where you're going to have to kind of, do the math and figure it out. All right, anything else?
No, all clear.
All right, perfect. All right, so moving on to applications, and this is what really, one of the things that really excites me about the equipment is the versatility, the customability. All right, so what kind of places can we see our unit installed? Attics, knee walls, crawl spaces, closets. If you want to, even underneath your bed, you might have a high pedestal bed and you're able to stick the unit underneath. And, not that I would ever recommend that application, but sure, if you wanted to, you could do it. And then getting into other types of installations, is it going to be a new installation, a new construction, right? New construction, a lot of times these homes are, being built to Energy Star standards. And being such, being that we are such a high efficiency heat pump product, we fit perfectly into those applications. All right, or is it a retrofit type situation where we are replacing like for like? So what does that look like? What kind of systems can we replace? All right, so first and foremost, gas and oil fired boilers, right? So your customer may have a boiler system in their home, and especially in the case of oil, those systems tend to be not so efficient. We could replace those, take those systems out as long as we have the room for ductwork. Now we are replacing a heating system with a more energy efficient heating system. And not only that, but we're including air conditioning into that equation as well. So that's what we could see as far as that's concerned. Then we have our standard unitary equipment or heat pump, right? We have that air handler up in the attic. Take the old air handler out, put our new heat pump air handler in there, and now that system may have only been air conditioning. Now we're giving them either a backup or a primary heat source, whatever they choose to do, just by replacing their air handler with one of ours, right? Because ours provides both. And then, this is really the reasoning behind, my idea of replacing my equipment, getting into the gas and oil fired furnaces aspect of things, because that's what I have in my home. I have a gas furnace in my basement for the first floor and a gas furnace in my attic for the second floor. And I am going to be replacing that equipment with our multi-positional air handler for a multitude of different reasons. Reason one, the efficiency, of course, but number two, the ease of installation. And you're going to hear me talk about the ease of installation throughout this PowerPoint quite often, or throughout this presentation, I should say, because it's not all PowerPoint. So the ease of installation, why is it so much easier to install this than, you know, just replacing my furnace equipment that is up there in my attic right now? Well, one thing, I don't have to hook up my gas. Being that I'm not hooking up my gas, I don't have to hook up my flue venting because I'm not producing flue gases. And lastly, I don't have to hook up the wiring that's there because my wiring comes in from the outdoor unit. So there's 3 phases of the install right there that are going to be time saving as far as the installation is concerned. So very excited about that. There again, you see it, the ease of the installation. One of my favorite things about this. There's a multitude of applications. There's ways to customize that as well, as far as the optional kits and components that can go with the system. High efficiency for all seasons, so we can cover you from 90-degree days in the summer to 10-degree days in the winter without a problem, and everything in between as well. Not only that, but we can dehumidify. All right, we have a dry mode, we have a fan-only mode, all built into one piece of equipment. And lastly, utility rebates, and not mentioned there, but possibly federal tax credits as well. So getting into some of those accessories here, I do have on the screen, I have my arrow up there again, and I don't want it, there we go. Okay, so up on the screen, I have this highlighted. That's the UTY RNR UZ4 remote. That is the remote that is recommended to go with this equipment. The reason why I personally recommend it, and I personally will be using it, is because it's a very easy, simple user interface with touchscreen. It looks modern. It's very simple to operate. It's basically one touch to get to your function settings, as opposed to the standard old remotes that we used to use, where we have to hit a series of buttons at the same time to access our function codes menu. So easy operation. These two go hand in hand. And not only that, but we also have a temperature, indoor ambient temperature located on the thermostat as well, so you can read what your actual temperature is. So a couple of things that we can install with the equipment. You can see the wireless receiver up at the top, the LBTUM, and that's basically if we want to hook up a wireless remote to our system and operate it from a wireless remote. We have our thermostat controller, the TTRX. All right, so the TTRX, if your customer comes up to you with a brand new Nest thermostat, they say, I want this to be hooked up with my system. Can you make that work with the Fujitsu? Yes, we absolutely can. We just need to order this UTY TTRX kit. All right, wireless LAN adapter. If you want to hook up the system to Wi-Fi without using a third-party remote, this is the adapter that you're going to get, the wireless LAN adapter TFS-XZ2. So a multitude of different things. We even have a remote sensor kit. All right, you can put one of these sensors in, some of the rooms, and we go as far as now even offering dampers for individual outlets. All right, so we can hook up an individual outlet with one of these remote sensors, and if one of the rooms happens to be lagging behind as far as the temperature set point in the home is concerned, this will continue to operate until it reaches that desired temperature. So we can go really from mild to wild as far as our controlling is concerned. All right, so getting to our heater kits, which I mentioned before, there's a couple of different kinds of heater kits available. The one that is most frequently used, the one that I like personally, is the A series that comes with a circuit breaker, which you can, I'm going to come a little closer here. You can kind of see what that circuit breaker looks like. All right, here is my heater kit. All right, so these are available in a multitude of different kilowatts. Remember, always when dealing with electric elements, it's always going to be 3,412 BTUs per element, per kilowatt rather. So when we are discussing the heater kits, or if we are discussing the electric elements on electric heaters, it's always going to be 3,400 BTU hours, okay? So getting to the sizing, because it does vary up depending on the tonnage of the system. Here's a chart right here that basically describes that, your mins and your maxes as far as our tonnage is concerned. So we can go from 2.25 all the way up to 15.5 on the 4-ton. All right. You know, and that's completely up to you on you know, your design to, you know, design it how you want. If you are looking to cover the whole BTU load of, you know, let's say, you know, keep the old the 36,000 that we were talking about before, to achieve 36,000 BTUs. If we go back to this, you could see we would have to install the 15 kilowatt. Where's my pointer? There we go. The 15 kilowatt to cover that 36,000 BTU load. The 10's not gonna be able to do that. It's going to be just short, actually. Actually, you probably would be able to get away with the 10 if you wanted to do it. I'm not sure. I don't have a calculator in front of me, and math has passed me a long time ago. Jim's going to calculate it for us.
What's a KW is worth what in BTUs, Bob?
3,412 BTUs.
3,412.
This is why we have Jim in the background to handle all this stuff.
That's right. So that's 34,120.
34,120 BTUs.
Yeah.
Okay. Yeah, that's right. Because when you're timesing by 10, you just add a 0.
Oh,
see, I told you that math left me a long time ago. I used to be good at it. All right. So yeah, your 34,000 BTUs would not be enough to cover your 36,000 BTU load. All right. So getting to our factory accessory filter base. Basically, what this is going to do is just an easy option as far as filtration is concerned. If we want to install, you know, a filter and have a nice easy access, we're going to install this filter base on the return side of our system. The only thing we want to make sure of is that we're not using a high density filter, because that will affect the static pressure of the system. Then we have our floor base, and this is going to be if we are installing the system in a vertical downflow position. Basically, as a fire safe, this goes into the base of the unit, and we want to seal that up with a fire stop caulk, just as a preventative measure. All right, so as far as the multi-positional air handler warranties are concerned, if you are just the kind of guy that wants to get in, install it, and move to the next job, we can offer our end user a 7-year compressor, 5-year parts warranty. If you do want to install, if you do want to register your equipment on your Fujitsu portal page, you are now able to offer a 10-year compressor, 10-year parts warranty. And if you do achieve the elite status by accruing 20 outdoor unit installs over the course of a year, and then reach out to either myself, Jim, John, Rick, or Anthony in our training department to get your 20 training points over the course of 2 years, we're able to give you this elite status where we can give a 12-year compressor and 12-year parts warranty. And that could be the difference between getting the sale and not, right? So you might be a little bit more overpriced than the next guy that comes in, but he can only offer a 10-year warranty or a 7-year warranty. And you can turn around and give this end user 12 years. That's comforting. People like to hear that they have an extended warranty on something. So you might be able to get a sale just based on that. Any questions, Jimbo?
You have 3 good questions here.
Excellent.
Jay wants to know, is there a way to manually adjust the static pressure settings, or is it only automatic?
That's actually a really good question.
Yeah.
It is, I know it's automatic from the factory. I don't know of any settings where you can make it manual. And I don't really understand a reason why you would want to make it manual.
Well, if he's designing his ductwork, I guess, and he knows it's static and he wants to set it. But the
Yeah.
advantage of the automatic is if
Right,
the filter's getting
right.
dirtier and dirtier, we
Right,
keep up,
yes.
so.
Yeah, absolutely. And I'm going to discuss that in a little bit.
Right. Another good question, I like this, somebody's really paying attention. Can the TTRX, T-stat converter, control more than one T-stat?
Yes. So the TTRX can control up to 16 different zones or 16 different thermostats. All right. So if you install a TTRX, you can hook up to 16 units up to that TTRX module.
Okay, Wi-Fi is not going away, so this question is there an app that allows control from a smart device?
Okay, yes. So with this, I'm going to go back a couple of slides so we can just show it. So with this wireless adapter here that goes with this system, this uses the FGL Air app, which is located on any one of your app stores, whether it's the Apple Store or Google Play Store. You can download that app, the FGL Air app, and then there's also a different type of Wi-Fi device that we have for some of our equipment that uses the Intesis app. That's INTESIS. So there's a couple of different apps that we use as far as the Wi-Fi capabilities are concerned.
That's spelled out in the catalog, right?
Yes. Yep. Absolutely.
All right, this one just came in. You mentioned Elite, so this gentleman wanted to know if there are any other benefits.
Yeah, so
To the Elite
there's a
program.
multitude of different benefits as far as the Elite status is concerned. Once you've reached Elite, if you can get your tech's phone numbers on your website and get your techs on the website, if they make a phone call to Fujitsu tech support and they're looking to get help with troubleshooting, they will automatically be entered into a higher queue above anybody who's not Elite, and they would get priority as far as tech support is concerned. So, on a normal day, normal summer day, Fujitsu can get upwards of, somewhere between 2,000 to 3,000 tech calls. And at the same time, they really only have about 60 techs that are answering phone calls. So you can understand why, those lead times on these phone calls could take a while. So if you can jump more than half of the group of people that are calling in, you got a leg up on the competition already. So there's that, and then they also offer some cashback rewards sometimes, depending on what promotions they have going on. You can earn X amount of dollars per 1,000 BTUs of outdoor unit installed. And basically you can use that for Fujitsu branded merchandise, or maybe if you want to do some Fujitsu brand lettering on your trucks or something along those lines, you have that as well. Let me go back to this question slide. Anything else over there, Jimmy?
No, you're clear.
All right, excellent. So next thing, getting into the installation here, I'm gonna go ahead and stand up and kind of stretch a little bit here to talk about this part. First things first, always knowing where to find your information is going to be very important. Okay, so each of our units comes with installation manuals, one for the indoor unit, one for the outdoor unit. Make sure we know and understand and have read through those manuals, because there's a lot of information you're going to be referring back to throughout the course of that install. Next, there is a series of manuals connected to each one of these systems that are going to be located at the Fujitsu website, the portal, www.fujitsugeneral.com. Under the product, they have a bunch of different manuals and what those manuals are. So the design and technical manual, the capacity charts that I was showing you before with the BTUs at certain outdoor and indoor temperatures, all of those charts for both heating and cooling are going to be found in your design and technical manual. If you want to know what your fan curves are, if you want to know how far your fan is going to be throwing air across a room, maybe you have a short room or something like that, and you want to know if you're going to have a problem with air deflecting back to an indoor unit, then that's beyond the Fujitsu Multipositional Air Handler. But you can find out those fan curves by going to the design and technical manual. Additional refrigerant charge, that's also going to be found in your design and technical manual on the Fujitsu portal. Then we have our service manual, and basically the service manual is going to have a bunch of wire diagrams in it, the wire diagrams for the entire system, both indoor and outdoor. It's also going to have some troubleshooting, so it's going to show some error codes. Not only that, but you have the ability to go right into the parts list. So if you are on a job, troubleshoot it yourself, you can get your part number, you can call your distributor and tell them, hey, this unit, under warranty, here is the part number I'm looking for, and makes it a lot easier for them on their end. So that phone call takes a lot less time. Then we have our service instruction manual, which is really one of my favorite things about the Fujitsu product and the ability to troubleshoot this equipment. You have all of this stuff right at your fingertips. All right. So if you call me and say, hey, Rob, listen, I got a problem with such and such a system. This is the error code that I'm getting. Can you help me troubleshoot this? Yes, I absolutely can. And I have no problem doing that. I do it quite often, quite frequently. But when I'm doing that, complete transparency, when I'm helping you troubleshoot, I'm going right to that service instruction manual. Okay. So that is available also on the Fujitsu portal. And not only that, but if you want to go to your app store, Google Play or the Apple Store, you can download the Fujitsu Mobile Technician app, and that basically is giving you that service instruction manual right at your phone. All right, so you can click in your unit number, your model number, your outdoor unit model number, your error code. It's going to give you all of the information as far as that error code is concerned and exactly how to troubleshoot it. All right, so it's a step-by-step, get yourself to the end point, and then go back to your service manual, go to your parts list, get your part number, call it into your distributor, and you just completely troubleshoot the unit without even getting Fujitsu tech support involved. All right, so the unit itself, here she is, very simple design. Up at the top, this is where our electric heater is going to be installed. So we take these two screws out, pull that plate off, and we slide our heat element right in its place. All right, so that slides right in there. Put the screws back in, holds it into place. Then you have your breaker, right, which I showed you before. The breaker actually gets mounted on the door cover itself, right here at the top. Punch this out, and that breaker fits right in that panel there. And then it has a nice little rubber covering that goes over that as well. All right, so nice and easy as far as that's concerned. Right below that, we have our fan motor. That is an ECM motor. All right, so very efficient, very well as far as the modulating is concerned. All right, and in front of that, we have our main control board for the indoor unit. Just a multitude of different things here that we could do. First of all, dip switch settings. Those are going to come in handy when we are going to be discussing our installation of our heater element, which I'll get to in a little bit. There's also a plug for our communication to our electric heat element. Our CN48, that we'll talk about when we are talking about the receiver. All right, board's pretty simple. Then we have our evaporator connected.
Your finger off the button.
My finger's on it.
Just temporarily. Just pick up your thumb. That's all. Sorry.
Okay. All right. Sorry. What is that, making the arrow move? Is that what's happening?
We're trying to get the camera to point at that, and we can't do it.
Oh, okay. All right.
Yeah.
My apologies.
It's all good. You're good.
Okay. Ready to go? Okay. All right. So here's our evaporator. As I was saying, we have our two thermistors, our room temperature thermistor and our pipe thermistor, both connected to this coil. And then we have our drain pan assembly right below that. And there's a other drain pan here for a vertical mount. So when we are talking about the mounting itself, right, we have our horizontal upflow, which you see here in this application. Then we have our left-hand left-hand blow from the horizontal position. And in both of these applications, we do not need to flip the coil. It sits exactly where it is, all right? If we have to go with a horizontal right-hand blow or a down flow, we are going to have to do a 180 flip of this coil. So how that is done, first we're going to cut out these little clips that hold these wires in place for our thermistors. And we're going to slide that coil out, flip it 180 degrees. Next, we have these two brackets that ship with the unit. And I'm not sure if you could really see it there, but these holes are kind of, as you can see, the holes are kind of offset there. All right, so being the way that they're offset, they can only be installed one way. There's little divots on the side of the unit that will directly coincide with those the holes on the brackets themselves. So you can screw those brackets in, flip the coil 180 degrees, slide it into place, reclip your wires for your thermistors, and you're good to go as far as that's concerned. All right, so moving forward, I just want to pull this off of the screen again, my arrow there. Okay, so taking a look here on the slide, you can see we have our unit hung with the supports going along the length of the unit. So across the length of the unit, both front and back. All right, I know a lot of guys out there like to hang the units from the short side. All right, we don't recommend that only because over the course of time, we have the ability to maybe possibly have that unit sink in the middle of that cradle where it's not supported. All right, next thing we want to make sure when we're in a horizontal position, always make sure that we are level both front to back and side to side to allow for proper draining. For maintenance, if in most cases you're going to be able to do this, we want to have 24 inches from the front of the unit to a immovable object. All right, so we want to have access to service it if need be. 24 inches in front. When we are installing this in a vertical up and down flow, we want to make sure that we are putting L brackets along the bottom of the unit for extra support. All right. Make sure when doing so that this coil is really there is only about an inch of space underneath. So we want to make sure that when we're drilling into the unit to screw these brackets in, we don't go more than an inch up, because then we have the ability to pierce the coil, and that's never a good thing. So as far as our piping is concerned, same thing along the lines of our standard mini split equipment. We are going to be using flare fittings and flare nuts. So the process involved with that is always make sure that we have a clean wheel, make sure there's no, chips or, divots or chew marks. Maybe a dog got a hold of it, or maybe you were a little extra hungry at lunch. Make sure that these wheels are clean and they are only for copper. Don't use a wheel that you've used on stainless tubing or, galvanized pipe or something along those lines. Make sure it's a dedicated copper wheel. Make a nice clean cut before you make the flare. And I know guys are going to be sitting there thinking to themselves how many times they've done this. Make sure you put the flare nut on the copper. I know I've done this plenty of times. I have about 20 years of experience in the field. 10 of those I was basically working with, mostly Fujitsu. So I've done this a handful of times, and every time I just wanted to smack my own head, all right, because it's such an easy thing to overlook. So make sure that we get that flare nut on there. When we're putting the flare on, we can use a little bit of whatever oil is in the system. In this case, it's going to be 410A. Put a little bit on the face of the flare, maybe a little bit on the face of the flare nut. That's really all we need. We want to make sure that we don't grab that copper and end up twisting our fitting. Okay, or twisting our flare, I should say. Hand tighten it, and then with a torque wrench. Yes, torque wrench, you must have one. I'm an old school kind of guy. I feel like personally, I could be the greatest tech in the world, but if I go to a job and I don't have the tools necessary, what really am I doing? That's personally how I feel. So if there's a tool that somebody says I need, I go out and get one, if not two, right? That's just how I roll. You can walk into my garage and see the plethora, using that word again.
Can you spell it?
Plethora.
Impressive.
You can see the plethora of tools that I have in my garage for various jobs, whether it's plumbing, construction, the whole nine. I have it. All right. If I don't have it, the day I'm going to need it, I go get it. Anyways, getting back to the copper, make sure you're using a torque wrench. All of the torque settings for specific copper sizes are always going to be found in the installation manual, so you always have the ability to just check out what setting you need to set your wrench to and go from there right on the job site without having to look too hard. And lastly, and this is where I lose a lot of you guys out there. All right, I'll ask the question, how high do you go as far as your leak testing when you're adding nitrogen to the system? And guys usually say right around the 250 to 300 mark. But our equipment can operate around the 500 range when we are in heating mode on a really cold day. So one of the things we want to do is we want to make sure that we're adding enough nitrogen to the system to cover what the system is going to operate to. If we're testing to 250 psi, but we're going to be operating to 450 psi, that could be the difference of finding a leak and not finding a leak. All right, so 450 to 600 psi as far as the nitrogen is concerned, and we want to let that hold for about 30 minutes. All right, once we see that it's held for 30 minutes, we haven't seen a drop in the nitrogen, we know there's no leaks, we're going to release that nitrogen. And the second part of this, and this is going to be a little bit more time consuming, but probably one of the most important things you're going to do in order to maintain the health of your compressor, evacuating the system down to 500 microns and allowing it to hold there for 15 minutes. So, being that I came from the field and being that I'm out on a lot of these jobs with a lot of my contractors in my territory, I see this happen all the time. Guys are evacuating the system down to 500 microns, and once their gauge reads 500 microns, close their gauges down, shut the evacuation pump off, and they're ready to move on to the next step. But that's not actually the case. If you watch the gauges, once you shut your valves on your gauges and you shut the evacuation pump off, those microns are actually going to rise and they're going to settle at a certain point. So if you bring that charge down to 500 microns and then you close your valves off, you could settle at 1,000, 1,200 microns, somewhere along those lines. And that's not going to be sufficient for our system. So what we really want to do is bring that down to 200, maybe a little bit less microns, close it down and see where that level, where it levels off. And if it levels off at 650 microns, say, we're not done with our evacuation yet. We have to hold at 500 microns for 15 minutes. No exceptions to this rule, all right? So getting to our condensate. All right, very simple. All right, you can see right down here, it's a 3/4 PVC male fitting that goes right into that slot. We're going to put a thin layer of Teflon tape or Teflon paste on the fitting itself. Hand tighten only. All right, if we try to use some sort of tool, that fitting is tapered. So what happens is we have the ability to expand the pan itself, and it does crack if you over tighten. Unfortunately, when I first came into the field, I was always working with ream equipment, so I'm very familiar with the setup to begin with. I did that and caused the pan to crack, and unfortunately, my boss was very upset with me about that incident. So make sure that we are not over tightening, using our hands only. Next, we have these two little drain plugs that come with the equipment. We want to make sure that we use them. We don't want to introduce any attic air into the system. We don't want to also, have the ability to spit water back out of those holes. So cap them off with the two red plugs. Same thing, they just screw right in. Hand tighten them. You don't have to go too crazy. All right, as far as the draining is concerned, we require that we have a 3-inch minimum P-trap. All right, you can use a running trap, but make sure that the running trap has at least a 3-inch drop. All right, if we don't have that 3-inch drop, especially when the return is on the, when the drain is on the return side, we have the ability to suck back in that condensate back into the pan, and eventually that's going to lead to water leaking out of the unit. All right. Next step, I always recommend, if this unit is going to be installed above a living space where we can cause damage to the ceiling below, the floor below, whatever it may be, to install a secondary auxiliary overflow pan underneath. All right. So if for whatever reason we may have some leaking from our system, it does not make it down and do damage to the living space, which can be very costly in some cases. If you think about it, once water starts dripping onto that ceiling, you don't know that water is dripping on that ceiling until it's too late. Maybe days have gone by before you start to see the browning of the ceiling. And by that time, that water could have worked its way, because water is very simple. It just follows gravity. It's going to work its way down walls, down to other floors and damage other areas, possibly grow mold. So make sure we're putting in an auxiliary overflow pan underneath. And with that, the system, if you're doing that, requires a normally closed position switch. So in this case here, you can see the float switch is in the pan. That switch is normally closed, and it's basically just sending that signal. All right, right in here, the 1 and 2 terminals, it's just sending a signal around. It's just checking to see that that signal always comes back. If that switch opens for whatever reason, that's going to tell the system that there is an issue with draining, and it's going to shut the outdoor unit off, so we no longer produce any condensation, thus eliminating damage to the ceiling below. Wiring of the system, once again, I've said this numerous times at this point, very simple. Our connection cable, our 14-3 wire that runs from the indoor unit to the outdoor unit, or vice versa, is going to be 3-wire plus earth. All right, 14 gauge. Our remote wire can be anywhere from 22 to 16 gauge. All right, when we are talking about the 24 and 30,000 BTU systems, we are going to have a 14 gauge power supply to the outdoor unit, as well as that 14 gauge 3-wire for communication to the indoor unit. Then when we go to our 36 and 48,000 BTU, we have to up that wire because it's a higher amp draw to an 8 gauge power supply to the outdoor unit. And the connection cable still remains that 14 gauge 3-wire. So how this all looks, taking a look here, you see we have on the right hand side our disconnect. That's our power from the breaker comes in on the L1 and L2 terminals with a ground wire. Then we have our 1, 2, and 3 terminals to the indoor unit going to 1, 2, and 3. Always wire them the same. That's my best recommendation, because if you go to a job and you see, you wired this system, you should see the same color wiring. If you wired it up and you see a difference, automatically that that's not the way I do things. I messed the wiring up. Always keep it the same. I always did 1, 2, 3, black, white, red. That will stick with me until the day I'm no longer drawing breath. I'll always remember 1, 2, 3, black, white, red. And then we have our ground wire as well. From our remote, we have a Y1 and Y2 terminal that comes into the Y1 and Y2 terminal here at the indoor board. And that's it. It's just a 2-wire, simple Y1, Y2 application. It just uses that, just those 2 wires to communicate. So very easy as far as that's concerned. And then right next to that, you have your 1 and 2 terminals. That's going to be for your float switch. That's all you have to do as far as the wiring is concerned if you're not installing one of our heater kits. If you are installing one of our heater kits, all right, as I've stated before, when you are installing those, you do need a dedicated line to the circuit breaker for the backup heater kits. All right, so keep that in mind as well. So on the RNR-UZ4, which you should be installing with every one of these installs that you do, there is a dip switch on the back. So in order to access that, there's 4 screws on that back panel. You just pop those off. And right behind there, you'll see that little switch. It comes in the on position. If you want to have your remote have a memory, if you lose power for about a week or so, you can enable that switch. That'll hold that memory for you if you lose power for an extended period of time. Moving on, next thing, the dip switches inside the unit. All right, so there's 2 banks of dip switches. If we are installing our heat kit, we need to go to the secondary, that secondary switch, which is going to be labeled switch 101. All right, you can see here, terminals 1 and 2, they are not going to be used. They'll stay in the off position. Terminal 3, we're going to slide that to the up position. That's going to tell us that when our heat comes on, we are going to continue to run for about a minute afterwards to take the temperature off of those heat elements in the system. All right. Then we have the LBTUM, which I spoke about before. If we are hooking this up to our system, we are going to be using this to control our system with a remote only, all right, not with the wall mount remote. One thing that we want to keep in mind, the wire that comes with this unit is only 16 feet long, so we have to be within 16 feet of that unit. All right, so keep that in mind. And that's actually what I said before, the CN48 terminal that I was talking about right there on the bottom of the board. That's where you plug this LBTUM in. All right, so static pressure. We did get this question earlier. We do not need to set the static pressure. It's always going to be automatic. Even if you do have the ability to manually set it, which I don't believe you do, I don't understand why you would want to. And the reason why is right after this, if we are looking at our system with a dirty filter, over the course of time, the filter gets more and more clogged. Nobody's maintaining it. What this system does, it actually reads the difference in the static pressure of the system, and it will actually ramp up to overcome the restriction in the system. All right, so that's one of the reasons why I don't think it really makes any sense to, to take that out of the equation and manually set the static pressure of the system. All right, so getting into our function settings, here is that fan delay setting I was talking about. So you can see switch 101, 1, 2 not used, 3 is going to enable or disable our fan delay setting. Auto restart in case of a shut off, loss of power, whatever it is, enable that auto restart to automatically go right back to whatever setting you were in before the loss of power occurred. Cold air prevention is a very important code when a very important function when we're talking about our multi-positional air handlers. And the reason why that is these units are designed off of the J series equipment, which basically has it's got like a 12-hour or 6 to 12-hour period where you're supposed to apply power to the system before you actually start it up. If you haven't done so, you actually have to go into these function settings to function 43 and disable that function to allow your system to operate. Keep in mind, when you do that, whatever your fan setting is on your remote is what that unit is going to set to. So we're going to kind of lose the modulation there. So before we are set and ready to leave the job site, we have to go back in there and re-enable that cold air prevention. All right, so that's very important. Room temperature sensor switching. So this is going to be if you want to control your remote, if you want your remote to control the temperature or to read the temperature of the room as opposed to the thermistor located on the inside of the unit. These two go hand in hand. Function number 42 is going to allow you to sense temperature from both the indoor unit and from the remote itself. And then function number 48 is going to allow you to go with either both or just the wired remote control. All right, so those are going to be something, things that you are going to frequently use on jobs, because we're installing this unit in an attic. There might be a little bit of a change in temperature as far as the air is concerned up there. So we want to read the air temperature in the living space itself. All right, emergency heat, function number 73. All right, this is to basically enable your emergency heat kit that we would install as a optional part. To enable that, function 73, setting number 1. And in order to control how long the fan runs, factory setting is 1 minute, but we could drop it to 50, 40, or 30 seconds if need be. All right, so we do have the ability to adjust that time as well. After all that is said and done, the installation startup checkpoint is going to be something that you can customize, for yourself, for your crew, and that's going to be just a series of checks throughout the installation. You want to check to see if your units are hung level. There's no, not going to be any issues with draining. Make sure all of your penetrations from the inside of the home to the outside of the home or business is completely sealed up. We don't want to mix any air from the outdoor, right? If we're installing a line hide, make sure the line hide's installed. Have you gone through and done your leak test evacuation and opened up your valves? Another very important thing, opening up the valves. And lastly, after all those things are said and done, the most important thing that you can do at this point in time is to explain thoroughly to the end user the functionality of both the system itself and of the remote. Because if you leave that home and there's something that they don't understand, you're going to be sitting down to have a nice dinner with your wife and kids, and you're going to get a phone call from a customer that says, hey, listen, I don't really understand what's going on with this equipment. Can you help me out? Right? Basically a nuisance phone call on your own personal time. Nobody really wants to answer those, but we're running a business, so we kind of have to. Let's make sure we're thorough on the job site the day of. This way we don't have to worry about those phone calls. And with that, I've come to the end of this presentation. I want to ask if we have any questions, if we have anything involving the installation process.
Yes.
Okay.
We're asked here, can we cut out the side of the air handler for return air?
Okay. So in some cases, in cases of a lot of furnaces, you can do so. When it comes to this air handler, if we cut out the side, we're actually bypassing our coil. So absolutely under no circumstances are we supposed to cut this cabinet out on the side. Okay. Keep that in mind. Our return is only going to come from the opening that comes from the factory, no other places.
Here's another one. This is a good one, and we're going to run into this a lot. If the unit can adjust static pressure, can we use it on undersized ducting? Whoa.
Yeah. So this goes along the lines of sizing as well. So as I stated earlier, when we are looking to size our equipment, always do a heat load calculation, manual J, right? Make sure that the unit that we're installing is the correct size for the application. Furthermore, let's think about this from a existing equipment. So let's say, for instance, we have a 2-ton system in this home, and we do our load calculation, and it turns out that we need about 30,000 BTUs for this application. If we are going to be installing this new equipment, my recommendation is, I'm moving my arrow a lot again. My recommendation is, let me put this down so I
Don't hurt yourself.
Oh, that might have been Chris in the background messing with me. So my recommendation is, if we are installing this in an attic and we can access the ductwork that's there, that's a little bit undersized, replace that with the right size ductwork. If, for some reason we do not have access to the ductwork and we can't get in there to replace it, yes, we can overcome the difference in ductwork sizing. Anything else?
Robbie, you're all clear.
All
Nice
right.
job, nice job.
All right. Thank you very much, everybody, for joining us. I hope you're very excited as I am about the product. If you are interested in more trainings from us, you can visit us at www.walesdarby.com, or you can go, click on the training link from the Wales-Darby website, or you can go directly to www.hvacinsiders.com, or you can even check us out on YouTube, on our YouTube page, HVAC Insiders. And of course, if you have any questions personally for me, I put my email address up there specifically for that. That's rclemens@walesdarby.com. And once again, thank you. I greatly appreciate you coming out here and spending your time with us today.